This short presentation has been created to help review some of the natural causes of climate change for GCSE Geography. People often get the greenhouse effect mixed up. It is actually a vital ingredient helping ensure all life on Earth exists. The gases in the atmosphere naturally act like an insulating layer, trapping heat. Without these gases, such as carbon dioxide and methane, in the atmosphere we would be too cold to survive or be able to grow anything at all. Before examining some of the natural causes of climate change, it is worth remembering that throughout the 4.6 billion years of Earth's history, the average global temperature has constantly fluctuated. In the last 2.6 million years, known as the Quaternary period, it has been up to 3 degrees warmer than today on a few occasions, such as 125,000 and 325,000 years ago during short interglacial periods, lasting about 10,000 years. The majority of past temperatures in the Quaternary period, though, have generally been a lot colder, with the Earth mainly being in glacial periods lasting around 100,000 years. Pause the show and look closely at the graph, paying special attention to the axes, with the dates being in reverse, going from right to left. Sunspots are a common sight on our sun during the years around maximum solar activity. They actually cooler bits than the rest of the sun's surface, found at places of strong local magnetic activity on the sun. The sunspots are like storms on the surface which create solar flares that send more ultraviolet radiation than normal towards Earth. Scientists, though, believe that the effect upon our climate change might actually be quite minimal. Pause the presentation to make sure you fully understand how these sunspots naturally affect our climate. It is believed that volcanic eruptions help produce our atmosphere by erupting out gases and helping cool the Earth down when it was first formed. When a large volcanic eruption occurs, it sends huge amounts of ash and sulfur dioxide upwards into the atmosphere. These act like a barrier to any incoming solar radiation from the sun by blocking its path and returning the heat back towards the sun. The sulfur particles also soak up any radiation from Earth. This means that on Earth it is much cooler than normal. 200 years ago, for example, Tambora volcano erupted, not only killing 100,000 people immediately, but also cooled the Earth by 1 degree, causing havoc due to loss of crops in the following years. They were known as the year without a summer. Pause the presentation to ensure you understand how large erupting volcanoes naturally cool down the climate of Earth. In the 1930s, Milankovitch argued that natural climate change was linked to the way that Earth moves around the sun and how it wobbles and tilts as it does this, varying the amount of solar energy arriving to Earth. The eccentricity cycle, lasting 100,000 years, links very closely to Earth's glacial and interglacial periods. The Earth's orbit is sometimes circular and other times elliptical around the sun. Our colder periods occur when the Earth's orbit is circular and the Earth is further from the sun during northern hemisphere summers. The Earth is naturally tilted on its axis, giving us day and night. The obliquity cycle, every 41,000 years, gradually alternates the tilt of the Earth between 21.5 degrees and 24.5 degrees. We get our summer when the Earth is tilted towards the sun. The Earth's changing obliquity doesn't actually alter the total amount of incoming solar radiation. Instead, it affects where sunlight hits the Earth. The third Milankovitch cycle is precession, occurring every 23,000 years. This is where the Earth wobbles on its axis, changing the direction it points in. This again doesn't change the amount of incoming solar radiation, but does alter the length of our seasons and which hemisphere is closest to the sun at different times of the year. Pause the show to make notes on how the Milankovitch cycles combine to make big changes in the Earth's climate. This is a brief summary slide based on some of the natural causes of climate change. We have looked at the role of sunspots and how increased activity of sunspots produces more solar radiation sent towards Earth, increasing temperature slightly. We've also examined how volcanoes have the ability to quickly reduce global temperatures after erupting ash and sulfur dioxide into the atmosphere, which blocks off any incoming solar radiation. We also looked at the Milankovitch cycles, showing that as the Earth tilts and wobbles, it affects the intensity of solar energy arriving. At the same time, we mentioned the eccentricity of Earth's orbit around the Sun, which also leads to different strengths of solar radiation arriving onto Earth over time. On the screen, we can also see a typical exam question. The command word discuss, which is shown in bold, expects you to write about this topic in detail, mentioning several different causes of natural climate change. Which do you think has the biggest effect? Why not pause the show now and have a go at this exam question?